All right, welcome back to another My First video in a long series of videos for those of you that are getting started in Sparx Enterprise Architect or UML modeling in general. Today we're going to talk about state machines. And I've been talking about state machines since the very beginning. I'll include a link to a video that I did, Fun with State Machines, over a year ago. It was like the 8th video I think we created in this channel. So what we want to do today is just introduce state machines. We're not going to do deep dives. I'll include a link. And if you want to do a deeper dive, you can watch that video and play along. All right. So let's get started. So as usual in these videos, we're going to start with the builder page. So I'm over in the browser. My browser's over in the right side, and we're going to select this for model builder, and it's going to take us over to the builder page. I've already typed in state machines, so it starts filtering out the ones that are available for you. Let's see here, use case diagrams. I'm going to skip over this one. We're going to go right to state machine diagrams. And the very first one is the starter state machine. And I would start here. There's a discussion. Sparx does a really good job of getting you started and training you in Sparx, especially on various state machines. All right. And then I'll let you go through these if you like. I think that the one that we may zero in on is the complete state machine. That's the one I showed you in the very beginning of the video. Create this one as well. This one I just used to get people started just on the state elements, especially initial and final, or start and end. But it doesn't have any choices or other elements I think that are important for the conversation. One of my favorites is down here in state machine simulations, and there are some really good ones. You also find these in the EA example file they include. But customer login, I just think that this is a great place for modelers to start in Sparx because it has everything I think that is important. And it even introduces and gets you started in simulating your state machines. You also have traffic lights, which I think is very interesting. Not choices or some elements in here, but it gets you started with a behavior that you can build into state elements as you're going through. When you start feeling comfortable with state machines, we go to the next one here. And one of the ones that I would probably use out of patterns is the very first one. So these are multiple ways to enter state. This pattern here is very useful for getting you started in how a state machine may lead into another state via various entry points. So this is a very powerful one to jump into. Another one is signal attributes. I think that this one, especially when you're getting into coding and the various behaviors between your states, this is a good one to get started on as well. Rolling down here, when you get into executable state machine case studies, there's a very interesting one here around washing machine. I think that this one is something that most can relate to. There's also some other very good ones that are there. And then the last one that shows up in the filter is around SysML. And SysML is a subject we'll do a whole series on. Probably going to wait for the release of SysML 2.0, but I may get it started because we've been waiting now for quite some time for that release. And a lot of people haven't even moved to 1.5. But in here in SysML, you have states and regions, this one right here. And I think that this one is very useful, especially when understanding how a state leads into a multi-region state and then can fork off. This is your fork right here, back in based on various outcomes or simulation within your state machine. So this is another one you might want to look at if you're in an advanced, I should say, modeler. But until then, let's just start at the very beginning and keep my first state machine as simple as possible. So what is a state machine or a state machine diagram? This is a type of behavioral diagram in UML that models the dynamic behavior of a system, object, or process. It shows the various states an entity can be in, the transitions between those states, and the events or conditions that trigger these transitions. State machine diagrams are especially useful for modeling systems where behavioral changes based on events such as workflow life cycles or interactive systems. So just as in activity diagrams, if we look over at the toolbox here, we have an initial, which is right here, as well as inside this state. And the initial, basically, just like in activity diagrams, is the starting point of the state machine. And this is presented by this dark filled in circle. Now, I'm not going to go through every element here that's in the toolbox, all the way down to these special ones that are down here. But I want to talk about the initial or start, and I want to talk about the final. All right. So the final is the endpoint in the state machine. And this is represented by this circle with a dark or black circle. I wanted to say ellipse that's inside of it. So that represents the final. You certainly have other ways to end or exit. You can see here in the toolbox, but we're going to keep this session as simple as possible. Next, we have the various states. So here we have 3 states that are in a state, and that is known as a composite or composite states. And these are states that contain nested states or substates, allowing hierarchical representation, as you see here. The state itself represents the condition or situation in which the object or system exists. These could be examples such as, hey, the state is idle, it's processing, it's completed, it's in error. There are many states that a state element can be in. Next, we have transitions, and these are these lines that you see here. These are transitions between states. And these lines with arrows that connect states, they basically are indicating movement from one state to another. So transitions are triggered by events or conditions, and we'll get more into that in just a moment as we create our states. Next, we have choice, and I'm going to roll over to Sparx login example. The choice, you'll notice, is in diamond form, which is what a decision form looks like. And basically, the choice element in a state machine diagram is a decision point that represents conditional branches in the flow of transitions. It allows the system to evaluate guard conditions, these are rules and so on, and determine which path to take based on the outcome. So these are very important for managing various forks, and forks are a little bit different, but a decision point is basically a 2 or 3, it could be more, decision point that forks out within your flow or your states. So those are the main elements that we're going to talk about or introduce today in my first state machine. So I'm in a blank work area. We're going to add a diagram right here, and the dialog box pops up for Sparx. This is the diagram builder page, and it is a behavioral diagram, state machine. Don't worry about these that are down here. We're just going to go with this top one, and we're going to create a diagram. So now we have a blank diagram, and we have the toolbox on the left to get started. Now, there's lots of ways to get started. You could bring in the state machine itself, and this brings in this element here. We're going to go ahead and call this just login, something very simple. It is a composite, meaning shown by this horizontal 8 here, this infinity sign. If we double click it, we drill down into a blank diagram underneath it with the state machine in it, and we can start bringing in various states. So that's one way to get started. I'm going to go ahead and say, no, I don't want to save that. And I'm going to hit Alt-G, find this element over here and remove it. And we're going to take a simpler approach. There are many ways to build state machines or start state machines. You could have class elements out of your code repository. And if we right click on this and we go down to new child diagram, you can create a state machine. You can give that state machine a name, and then you could do state in here. That's another way. And then yet another way is via scenarios from use cases or other elements. You could come in here on your element, you could do a scenario, build a scenario, and then from the scenario, you're able to generate state machines. Have other videos on that, but we're going to, once again, keep this as simple as possible and just work with the blank diagram. So when I'm starting a state machine, I usually will bring in an initial, just drag and drop that in there, and I will bring in a final or end, all right? So here's an exit. I'm going to choose that, or final would be the smarter one. So there we go. Just bring them in. Often they're optional. Just start here because we want to go everything in between this. And then I start bringing in states. Now, our use case is login, all right? And you can look at the customer login state machine that Sparx has provided. It is a little high level. We're going to do something a little bit deeper level, potentially around a real login or access management state, but we're going to keep it very simple. So our first state is logged out. They're not logged in. So we're going to start there. Customer doesn't enter, user doesn't enter, machine doesn't enter in as a login state or logged in state. It's logged out. All right. And we're going to add in some other states that are important. Let me do that offline and be right back. All right. So I brought in 5 other states here. We've got logged out. We have logging in, right? And then we have, well, they failed to log in, or they were successful at logging in. Could be they've been inactive for too long, whatever the rules, constraints, or thresholds are. So the session timed out, which is going to log them out automatically. And then we have locked out. And if you have rules such as we allow them to enter their password 3 times, if they fail 3 times, we're going to lock them out, whether permanently or for a period of time. You also may flag users in your database that you want to permanently lock out. They could be fraudulent users or for other reasons, you're going to lock them out, all right? So these are the states that we're going to start with in this model. Doesn't matter how you've organized your elements, just get a general idea how you think they're going to flow. And logged out, I'm going to have lead the final. Logging in is going to be the initial. I'm going to want locked out as prominent because that's very important in access management. And that's going to be due to failed. Ultimately, the happy path is they are authenticated. So they're logging in, successfully entered their username and password. They're authenticated and they're off and away to a great customer experience, right? And then session timed out, we're just going to move down here. Now we're going to need to make some decisions along the flow here, the path. So we're going to bring in a choice element. I'm just going to click, and then I'm going to click somewhere around here from leading from the login, and there's going to be a choice. And Sparx tags it choice for you. You could blank it out. It's not necessary. And I'm just going to put it anywhere in here. So basically, when they're logging in, they are going to get to an evaluation decision. All right. And so we're going to bring in another choice. I'm going to bring it over here somewhere. And we're going to evaluate their login credentials. All right. So basically, when they're logging in, we're going to go over to this choice first, and we're going to bring in our very first transition. So we're transitioning from logging in to evaluating the login credentials. All right. So I'm going to put this somewhere around here to get it out of the way. Now I can select in here and hit Control Q to create a break, or I could change this to orthogonal square, and it gives me the ability to move this line anywhere that I want, and it'll square it off for me, all right? Now, evaluating the decision point here is going to lead to two different states. One is authenticated. This is the happy path. And the other one is, well, they failed, right? And we're going to allow them to make some other attempts to log in. And then if it failed, then we're going to make a choice, whether to lock them out or whether to allow them to log in again. So we're in our choices here, we're going to have it go here, or it could go loop back to transition to logging in, another login attempt. Now, again, you can change this to orthogonal square off your lines, or you can do it at the very end. Totally leave it up to you in what you want to do. All right, so there we go. Let's do something like this and organize our transitions. Or what we could do is right click here, go down to apply line style of the same type, and it will make everything orthogonal square. So this particular line here, it made it orthogonal square. And then here's the happy path, logging in, put in username and password, and now they're authenticated. So now that I've modeled here, I'm going to start moving my elements around that make more sense. All right. So we have initial leading into, well, they're logged out. We need them to log in. And we could, to final or close this, there's lots of ways that we may end up here. So logging in, or they're authenticated rather, this is going to lead to them logging out naturally, or we're going to force them. Force them is session times out, and it's going to transition to final. Logging out is going to transition to final. Logged out is going to go to final. And there's lots of other things that are going to get us to final, like if they're locked out, well, that's it. So that could transition to final, right? So let's draw in some other transitions. So locked out is going to log them out, force logged out. What else here? This choice can lead to logged out. So there's one that's taking place. And let's see here, authentication, if they're sitting around too long or inactive, that could be a session timeout, right? And that can lead to a fine out, or even go here first like this. Matter of fact, let me escape out. Let me grab this arrow here and do something like that. And then I can make everything orthogonal square everything off so that I can grab them and manage them. So there we go. That way I can grab this, and I'm going to have to control Q it anyways to make a break. And there we go. All right. So, and then that would lead to a final, right? So a lot going on in this. There's some plumbing issues, and you can try to clean this up more if you want. Let me do a little bit of that, and then let's continue. All right. Congratulations. You just did your first state machine diagram, and there's so much more to talk about. We could talk about simulation. If you want to simulate this, just right click anywhere in the white space, go down here. We don't have any code, so it's going to be manual, and you could run simulation, all right? All the way to final, or all the way through to test the states, the choices, and other things that you've included in your state machine diagram, all right? And again, I included a link to a video. It's a little more advanced that I did quite some time ago. We do other state machine examples throughout the channel, and I will do more as we go forward. So we're going to go ahead and close out. I'm trying to think if there's anything else that I needed to cover. Please let me know down in comments down below what kind of questions or concerns do you have. Are you using state machine diagrams? Do you find them useful? Do you want to know more about state machine diagrams that helps us drive content in the channel? And also what challenges you're having with your team and such modeling practices. Some teams don't do enough modeling. They get right into delivery and they make a lot of mistakes that cost the shop a lot of money and time. Modeling is the most valuable thing as we can use in our delivery. And there's all this hype, and I'm going to do videos around AI and the ability to auto-generate code, even auto-model for you. But right now, we're not there yet. We're working on it, but we're not there yet. So modelers as developers potentially can be replaced. I really don't think it's going to replace all developers. The advanced or chief developers, senior developers are going to turn into architects, and architects need to know how to use computer-aided software engineering techniques, whether it's with UML or some other tooling. So there's so much more to talk about. I hope that everything is going well for you as you're adopting these practices. And until that next episode, happy modeling.